Once upon a time, there was a big American city that had a little problem, a garbage strike. As the days went by, the little problem got bigger. And bigger. Stacks of sacks. How deep can this get? In the better parts of town, they had very high-class garbage. But in the low-rent areas, they had very common garbage. But it's a funny thing, all over town, swanky areas and slums alike, things smell just about the same, pretty stinky. Finally, the people of this big city settled their little strike, and many of them to this day remember the moral of the story, that effective solid waste management is essential in this complicated 20th century urban civilization. Only if we protect and preserve the natural environment can man survive. Our discards, we call them solid wastes, jeopardize our continued existence. The landscape becomes littered with dumps. And then to reduce the volume, we set fire to them, thus diminishing one problem and creating another, even more insidious one, air pollution. Americans throw away over 5 pounds of refuse per person per day, a staggering total of nearly 200 million tons a year. Unfortunately, pollution is proportional to people. Collection and disposal problems become aggravated when people live in concentrated areas. It costs New York City $30 to collect and dispose of a ton of solid wastes. Throughout the country, 13% of the population has no refuse collection service. This results in indiscriminate dumping, which litters the landscape and creates health hazards. The President and the Congress have indicated great concern, and programs are now underway to assist local communities. The federal program, which includes a wide variety of research and demonstration grants, is predicated on one fundamental principle: we must develop a better system. Ever wonder how solid wastes could be handled more effectively? Some new ideas from the Environmental Health Service. Here in a University of West Virginia laboratory, a new concept of incineration is being investigated. Refuse, already ground to uniform consistency, is fed into a fluidized bed reactor, equipment commonly used by the chemical industry to obtain controlled reactions between gases and solids. Here the modified pilot reactor becomes a furnace. The gas is air, moving up the column under pressure, and the suspended solids are a mixture of particles of burning refuse and inert sand, which serves as a heat sink. This is a simulation of the reaction occurring inside the furnace as the particles reach a fluidized state, resembling boiling water at combustion temperatures. The development of fluidized bed incineration is one of many varied projects conducted with federal aid under programs of the Bureau of Solid Waste Management, a branch of the Environmental Health Service, Public Health Service, U.S. Department of Health, Education, and Welfare. The incinerator is still experimental, but it already promises more complete and cleaner burning. Demonstration project personnel examine the residue, which constitutes only a small fraction of the original volume of the refuse. The fluidized bed incinerator stack emission contains far less particulate loading than conventional incinerators. Another university research project is examining hospital wastes. Think how diverse they are. In addition to the ordinary ones, garbage, paper, and other dry combustibles, and non-combustibles such as bottles and cans, hospitals generate unusual wastes related to medical treatment and surgical procedures that require special handling and disposal. In order to develop data on the nature and volume of the various waste materials and to devise better management methods, they are identified and carefully separated. Analysis of the different materials and their processing may even point to desirable changes in the design of hospital service areas and waste handling equipment. Glass has few equals as a container. It's chemically inert, won't react with any other substance. That's good. But once millions of bottles and jars are discarded, they won't burn or degrade. They just lie there taking up space. That's bad. This team of Clemson University scientists is making glass with a difference. It's soluble in water. But what good is it for holding, say, soda pop? Well, first it's put into a chemical vapor deposition apparatus and coated with a very thin film of inert material. Then it will hold anything. Break the film, and the glass slowly dissolves. So does the solid waste handling chore. Chickens and other animals concentrated in commercial cages and feedlots contribute increasingly to the solid waste load. In this University of California experimental closed hydraulic system, water flushes the manure to a high-rate oxidation pond. There, its nutrients are reclaimed photosynthetically in the production of algae. The digested sludge can be used as fertilizer, and the dried algae as supplemental food for ruminant animals. Resources from waste through research. These students inspecting an abandoned strip mine are a new breed. Their graduate studies emphasize environmental control. Several universities are expanding their curricula to provide qualified engineers in this crucial area. Recognition that specialized training, as well as imaginative research, is essential for effective solid waste management and the total protection of our environment. Solid wastes are in the bag in Barrington, Rhode Island. The heavy paper container holds mixed refuse and is deposited bag and all in a sanitary landfill. The simple, efficient system, after 3 years' demonstration, is proving easier for householders, a time and labor saver for workers, cleaner and more sanitary for everyone. Townspeople favor the system, and a sharp increase in the volume of wastes collected indicates they're making greater use of a better service. In a rural community, house-to-house collection is economically unfeasible, and random dumping and littering is unbearable. Chilton County, Alabama found a solution. It's keeping itself clean and green with a network of neighborhood storage receptacles. Residents deposit their household refuse whenever it's convenient. The containers are emptied twice weekly, and the accumulations placed in a central sanitary landfill shared with the county seat of Clanton and 3 smaller municipalities. These cities continue to provide house-to-house collection, but have closed their open dumps. Throughout the county, about 90 small random dumps and their rat populations have been replaced by about the same number of handy and tidy containers and 1 specially equipped truck. A pretty fair exchange. The container and truck idea is applied in a different way in Wichita Falls, Texas. Here the containers have wheels. The waste load is transferred to the mother truck for disposal at a sanitary landfill, while a train of containers is used to make collections along the route. All data on routes, load weights, equipment, and personnel usage are computerized daily. Data analysis relates the type and volume of waste generation to land use, residential, commercial, and industrial, and will permit development of a complete management model, simulating the container train collection and disposal system. With this model, optimum use and expansion can be projected as population grows and land use patterns change, demonstrating a systems analysis approach to solid waste management planning. An open dump is bad enough. A burning one is worse. Fire consumes some of the combustible waste, but scourges the area with smoke and ash, and rats and flies survive it. Here at Kenilworth, in the heart of metropolitan Washington, D.C., a burning dump was transformed into a model sanitary landfill under a health, education, welfare demonstration grant. Deliveries of refuse and incinerator residue were spread and compacted and completely covered with 6 to 8 inches of earth by the end of each day. The completed fill, contoured and graded, is being developed as a recreational area by the District of Columbia and the National Park Service, demonstrating the value of the sanitary landfill technique in reclaiming a blighted area. Another kind of scar on the landscape, an abandoned strip mine. Suppose it could serve as a burial ground for solid wastes and be reclaimed in the process? Sanitary landfill demonstrations are being conducted at this mine site and 2 others in Allegheny County, Maryland, by the county, the state, and the cities of Frostburg and Cumberland. They provide centralized service to 60,000 people, have eliminated Cumberland's open burning dump and smaller scattered ones, and will eventually restore these old mining sites to their natural beauty. Here's a small mountain of refuse near the Atlantic Ocean at Virginia Beach, an innovative sanitary landfill conceived by the State Director of Virginia's solid waste activities. It will take all of the city's refuse for several years to build Mount Trashmore, as the wags call it, to a height of about 60 feet above ground level, a bowl around an artificial lake, and something of a landmark in an area of flat terrain. A very useful landmark, though. Grading already anticipates its ultimate purpose. Someday this will be an expanse of seats, an amphitheater with a soapbox derby track, and other facilities for the enjoyment of this coastal resort's residents and visitors. Some coastal communities are considering disposal of their solid wastes by dropping them well offshore at sea, but too little is yet known of the ecological effects of this practice. Certainly, most of the nation has no choice but to use the land for disposal. In the process, the land can be despoiled, or it can be protected and enhanced. Sanitary landfill techniques make the difference. This prototype press is known as the Monster. Perhaps it should be called the Magician. It makes solid wastes disappear. The machine receives refuse by the truckload, and in a series of coordinated operations, compacts it, extrudes it in the bottom of a trench, all the while digging the trench, backfilling it, and compacting and leveling the earth. This new variation on the sanitary landfill concept is being used on a 100-acre site by the Niagara County, New York Solid Waste Agency. Its members include 8 of the county's 12 towns, as well as the cities of Lockport, North Tonawanda, and Niagara Falls. The agency disposes of the solid wastes of 250,000 people and is demonstrating and evaluating a novel new landfilling machine. Here in King County, Washington, which also includes the city of Seattle, solid wastes are being loaded into another prototype landfill machine, this one constructed to the county's own specifications. The mole performs about the same functions as the Monster, except that the trench is excavated and backfilled by auxiliary equipment. The monster and the mole represent new concepts in sanitary landfilling, and a great deal more experience in their operation is needed. They may prove feasible and economically practicable, largely under conditions where established sanitary landfill techniques cannot be used. But in such special situations, their contributions to good solid waste management will be invaluable. The possible advantages of grinding solid wastes in a hammer-type reduction mill before deposit in a landfill are being demonstrated by the city of Madison, Wisconsin. Milling refuse substantially reduces its volume and effectively extends the life of the fill site. The mill is simply constructed, easy to operate and quite reliable. The milled product spreads easily on the fill, compacts and grades well, and settles less than unmilled refuse. The product is not odorous, and a control area left without earth cover has attracted no rats. Observations so far indicate that the quantity of material rejected by the mill is quite low, and that the use of the milled refuse considerably improves the quality of the landfill. Milled refuse is also being composted in several projects, such as this one conducted by the joint U.S. Public Health Service Tennessee Valley Authority composting project at Johnson City, Tennessee. Composting is not the one miraculous solution to all disposal problems, but it does convert organic refuse to a useful product, and in some situations may be more practicable than landfilling or incineration. Incineration is like the little girl children sing about. When it's good, it's very, very good, and when it's bad, it's horrid. About 360 incinerators handle almost 10% of the nation's total waste load, but no more than 50 of these facilities are adequate. Some of the others can be remodeled. The rest should simply be replaced, and additional ones will be needed as the volume of solid waste increases. The Shippensburg, Pennsylvania Sanitary Authority is demonstrating a new type of incinerator because it must dispose of the solid wastes of some 12,500 people without a suitable area being available for a sanitary landfill. The combustible refuse goes into a facility specially designed to meet air pollution control standards and eliminate environmental health hazards, while reducing the refuse to the smallest possible volume. The heart of the furnace is this stainless steel perforated drum, revolving in a steady stream of air like a giant clothes dryer to achieve maximum combustion. The rotary grate incinerator, as it is called, may prove to be an efficient, economical means of solid waste disposal for many relatively small urban areas. An incinerator stack shouldn't smoke. This one doesn't, except when it's made to. It's part of an experimental furnace built to study the control of emissions. Through the nozzles ringing this firebed, directed streams of air can be introduced for cleaner burning. As investigators alter combustion conditions, they monitor the composition of gases flowing upward through the stack and into the atmosphere. 70% of America's municipal incinerators do not have adequate air pollution control devices. This Environmental Health Service staff research project is representative of the efforts to advance the technology of incineration. A grape vineyard next to an open burning dump just doesn't make any sense. The dump is closed as all local cities, the county, the state, and the federal government cooperated to devise a unique trailblazing study of the solid waste problems facing a 1,200 square mile area, including the city of Fresno, California. Uncoordinated methods of handling municipal, industrial, and agricultural wastes were analyzed, and a total integrated waste management plan devised. Most plans are concerned simply with handling wastes. The Fresno study, using systems analysis, focuses on managing solid wastes to achieve the desired end product throughout the urban-rural region: unblighted land, clean air and water, a pleasant, healthful environment. Sanitary landfilling and composting are emphasized, with very little incineration and greater resources recovery as a future goal. The more we consume and use, the more we throw away, an endless stream of solid wastes with technical problems and environmental dangers that have become national in scope. These research, development, and training activities are a portion of the national search for new and improved methods. There are many more projects, and there will be many others, all supported in part by the U.S. Department of Health, Education, and Welfare under the Solid Waste Disposal Act, providing federal assistance to the technological advancement of solid waste management. Whether local and state governments and private enterprise can apply the advancements depends upon the willingness of the American people to bear the cost. Saving the environment will be expensive, but then another one isn't available at any price.